Thanks. It's actually been a minute since I was last on a LUG stage. I think it was 2015, and my talk, coincidentally, was HSM in the cloud. So it seemed kind of like a crazy thing back then. Today we're talking about multi-tenancy, and yesterday Sebastian talked about some of the new features in multi-tenancy. So what we're doing here is not really going into detail of the features. We're showing how adding those features and some other things into multi-tenancy, it creates a much more compelling solution now for multi-tenancy. So this is more of a demo than a technical talk. And the demo are just recorded videos, so hopefully they'll actually work. So first of all, let's talk about different models of multi-tenancy. So there's a few different ways you can approach this on Lustre. And the one that's the most Lustre-oriented, of course, is the one that's based on node maps. And that's certainly the main thing we'll be covering, but there are other options. So node maps are multi-tenancy that's based on collections of nodes, or NIDs. So a node can only be within one tenant, and a tenant is just a collection of those nodes. And typically you do use network separation and to create VLANs or more modern approaches to VLANs, and that creates a very secure separation between different tenants. And the idea is in the node map, you could create a subfolder or a subdirectory, which is private to a particular tenant, and you can and that's managed within node map. So another kind of multi-tenancy would be not using node map at all, but using containers to do basically CPU isolation. Or compute isolation. We don't have the true isolation on the file system side, but with a custom CSI driver, you could have it create a subfolder, create a project ID, set a quota. You could do some multi-tenant-like things in Lustre, but it's not true multi-tenancy. And it really comes down to the fact that the multi-tenancy is based on nodes, and in this kind of case, we need to be able to support more than one tenant or container on a single node. And then there's the multi-single tenant, which is basically the cloud approach, where each file system for Lustre has its own completely independent set of resources, its own servers, its own storage network, and so on. It's not really multi-tenant from the Lustre perspective, but from the cloud perspective, it has multiple file systems, so it's a kind of a multi-tenant. We're not going to be talking about this one much more. I just wanted to point it out that this is another form of multi-tenancy. So in 2.17 now, we do have some interesting changes. And so in the demo that we're going to be showing has an environment similar to this. It's basically this setup, but for some reason the storage sizes on the clients are not the actual storage sizes. This demo was created on a laptop with virtual machines, so it didn't have 600 terabytes. But what we do have are separate VLANs for each tenant and a separate VLAN for the storage. And that's all created dynamically. So we'll be setting up, we set up a server VLAN, make sure all the servers are connected to each other, and have a server node map and a default node map. Then we'll start onboarding tenants. So again, this is the storage VLAN. What we have is just some OSTs, MDTs. There's two servers. Each server has two NIDs, just like you would in a normal setup with failover. And just pointing out that when we format these servers, they only have the NIDs of the storage LAN. So those NIDs are only accessible to the storage servers. So the clients can't access those NIDs. And so in order to make this work, we have to create a node map for the servers so that the servers have access to all of the other servers, and the admin client or the storage admin client can access the actual underlying file system. So this node map is specific for just the storage VLAN and not accessible. There's also a second node map called the default node map, which in this case is rejecting all clients. So basically, if a client tries to mount Lustre and it's not in the storage VLAN, it's not an admin client, then it just gets completely rejected, because now there are no tenant node maps created. So let's add a tenant. In this case, So we're using a few new features highlighted in yellow. One is the ability to add an ID range or offset. In the command line, it's called an offset. And the idea is you can give each tenant some number of IDs, that is UID, GID, and project ID. In this case, we're doing 100,000. So every tenant gets 100,000 IDs to work with. And inside the tenant, they're numbered 0 to 99,999. Every tenant has that same set of numbers, but outside the tenant, those numbers are added to the offset. So for tenant 1, it's added to 100,000. Tenant 2 would be added to 200,000. In the demo, we'll show what this looks like in the file systems, both in and out of the tenant, so it hopefully will make some sense. There's also a feature added on the very bottom on the right. We see the local admin feature. This is an RBAC capability added in 2.17 that allows the root user in the tenant to have root-like permissions to modify files on Lustre. So it can change permissions, change ownerships, set quotas on users inside the tenant. Even though that user is not on the file system, it's not an actual root user according to the file system. It's user 100,000 or whatever. And then we add a tenant directory. We make sure that directory is owned by the root user of that tenant, which in tenant 1's case is user ID 100,000. And then we're also setting a quota, and those are the quota commands on the right. And finally, we'll dynamically add the tenant network. And this is using dynamic NIDs that was demonstrated yesterday. We're creating a new VLAN. We'll add the devices on the servers, add the NIDs on the servers, and then be able to mount the client. And so the next step is, this is the first video that we'll start, and hopefully, yeah. So we've got the IP addresses. There's the default in the Lustre server, node maps at the top. Does anyone know why LCTL node map prints the help below the list of node maps by default? Yeah, we'll see that again. There's the ranges for, this is the, these are the servers, actually. That's the server VLANs. And now we're watching Ansible do all the magic, hand-wavy stuff. So one thing to point out here, although we're adding network new NIDs, new networks, we're not unmounting the servers, we're not running 2E2FS. It's all using the dynamic NIDs imperative recovery approach. So here's the new interfaces added on the servers, and then now we'll add the NIDs. So there's new NIDs on the server. And I think, yeah, and so what we're doing now is mounting Lustre on the server, and because we're on the server, we can mount the whole file system. And we are looking at the directory that was created by the Ansible scripts. It's owned by user ID 100,000, and the quota was set to 3 gigabytes for project ID 100,000. And now this is on the tenant, on client 1, and we've got the IP addresses, and we're mounting Lustre using the tenant's VLAN IP addresses, not the storage. And we've mounted Lustre. This is the Lustre the tenant 1 directory in Lustre, and it's an empty directory. And notice this is regular DF, but it's showing the availability as what the quota is set for that tenant, 3 gigabytes. That's normal DF. And I'm just creating a file. And now we're back on the server, and we're looking at the tenant file, and you see it was created by root on the tenant 1, but it's still user ID 100,000 on the canonical ID on Lustre. Okay, that's demo 1. And then this is the rest. We'll just do the other 2 tenants and do a few more things. Now we've got 2 more VLANs added, a lot more NIDs, and we've got more node maps added, and also helpful hints. There's another one of the range for the VLAN 102, and then I think this will be VLAN 103, and it should, the new tenant directories, notice the user IDs are 200,000, 300,000 for those offsets, the roots plus the offset on those tenants. And then the quotas for the two new projects are 2 gigabytes and 4 gigabytes. Now on tenant 2, we're mounting the file system using the tenant 2 VLAN. Again, empty directory, and that's DF showing the file system size is 2 gigabytes, what the quota was. Unfortunately, we forgot to do a DF of the actual underlying file system, so I don't know how much storage was on it. Probably like 10 gigabytes or something. So this is on tenant 3, doing the same thing, mounting the file system and creating a file. And then we'll go back to the server and look at all of the files on the server from the server perspective. And tenant files and the different UIDs for root in each of the tenants, they're just normal users as far as Lustre is concerned outside of the tenant. So in tenant 1, we're going to, so now what we're going to do is the admin user in tenant 1 root is going to create a quota for one of the users, user 1000, which in this setup, because we used Vagrant, is the Vagrant user. So there's the Vagrant user with its own quota, which was set by the admin user, just the regular user, but inside the tenant. So it's not a Lustre super user, it's just the user in the tenant. And now we're creating a directory for the Vagrant user. We'll create a file in there, and then we'll look at it on the server side. Allocating file. And yeah, so we've got a file and a directory that's owned by Vagrant. I'm not sure why we did that. And also just showing that this is the Vagrant user does not have the local admin capabilities. It can't write a file in the mount point, which is owned by root. And on server, we'll just list all those directories, or the tenant. So here the UID is 101,000. The Vagrant is user ID 1,000, so plus the offset. On the file system, it's shown as 101,000. Okay, so another nice feature we have now is monitoring tenants. So there's now a new parameter nodemap.star, which has both data stats and metadata stats. And by scraping them, you can put them into Grafana. So that's a nice plus. So for 2.7 summary, we've got definitely some huge improvements in multi-tenancy. Dynamic NIDs really makes it much more seamless to add and remove tenants. I wish we'd had removing tenants in the demo as well. It's just the same as adding them. You don't have to reboot anything or unmount anything on the servers. Of course, you unmount the clients. But we have the isolated namespace. So there's some other improvements there you can peruse. That's that. So what we have now coming up in 2.18, and actually I want to go back real quick. In our demo, we also included those 2 patches on the bottom right for dynamic NIDs. We needed those extra patches. So this is 2.17 plus a couple of other things. I forgot to point that out earlier. So now 2.18. So some of those challenges we talked about for multi-tenancy was in particular, the single client, a node not being able to be in more than one client. So you can only have more than one tenant. So a node can only, since tenancy is determined by the nodes or the NIDs, then it's not granular enough to provide some of those other use cases, like using containers. Another problem we've got is that project ID quotas are only done on just the overall project ID on the folder. So it's just project ID 100,000. All the other project IDs you can manage in the tenant, you can't set quotas on those. And so there's a feature called LQA, which will allow you to do quotas or manage quotas for individual projects within the tenant. And then we'll also have no support for secure authentication for tenants. And so here's the LQA I was just mentioning. The tenant quota can be managed by project inside the tenant. And you can do it either from outside the tenant. Well, you see those quotas. You can use, again, 0 to 100,000 on project ID gets maps to different offsets on the actual file system. This is the GSS feature that Sebastian was talking about. You can use keys to mount at the mount point instead of the IP address qualification or native qualification, so that we can have multiple tenants per host. And this would integrate very nicely with container-based multi-tenancy. And another cool feature is using the TBF, the token-based filtering NRS scheduler, to do some quality of service, QoS limiting of tenants on Lustre. So what we've got here is another demo, last one. And what we're running is the same 3 tenants that we had before, and we're running, I think, FIO generating a workload. And what we see in Grafana here is, let me pause that. So, oops, too fast. Let me start that again. So I wanted to pause that. That went forward. Okay, so all 3 tenants are getting about 600 megabytes a second. And so what we're going to do here is go and set the TBF with token-based filtering. In this case, you can set a rate parameter. And so we're going to set a different rate for each of the tenants. So 100, 200, and 300 for the tenants 1, 2, and 3. And that means it's setting the IO rate to that number for each of the tenants. The FIO that's running is basically, it's doing 1 megabyte operations. So, and again, this rate limit is on the RPCs. It's not on megabytes or anything like that. So we have to, figuring out the actual QoS setting that you want to use for each tenant does involve, it can be quite complicated because it's per server and it's based on RPC rates, not actual data, and not bytes. But since we're doing roughly 1 megabyte RPCs and limiting to 100 or so, or 200, 300 RPCs, then we'll see that kind of rate when we go back to Grafana. And just let it catch up. And yeah, so tenant 3 with 300, it's 295, 197, and 100. So that's actually working. So it needs some usability improvements, but the fundamentals are actually working. And here's a list of other issues. I don't think I have, maybe I do have time, but I'm not really prepared to go over all of these. Just a bunch of other tickets. And then, yeah, for 218, this is, so with improved QoS, secure clients, and the project, the ability to manage quotas at project level in the tenants is really going to, another big jump in improvements for multi-tenancy coming up. And by then, this will really start looking like a first-class multi-tenancy capability, but we'll have to see. And I do have some other references back there at the end. So, yeah, and if you're interested in node maps, but I mean, I didn't cover any of the fundamentals of node maps. Sebastian has done some great LUG talks previously that covers node map. So, any questions? Oh, okay.
So it's worthwhile mentioning that, like in the last week or two, there's a patch for NRS TBF to specify rates in megabytes a second. So
Fantastic.
there you go.
Still per server?
Still per server, but the goal is to make it have some sort of exchange so that they can, balance the rate across all of the servers rather than just on a per server basis.
Wow.
But
Yeah,
I mean,
great.
that's not, that part is not implemented, just the per server
Yeah,
bandwidth.
yeah. Yeah, a week earlier than Matt could have gotten that when he made the demo. So, I also want to point out that all the work for here was done by Matt. That's why his name was on the presentation. So he should get credit for all of that. It's his ideas. Thank you.